Hello guys, welcome to my YouTube channel of Debneel's Mathematics Desk. So as you can see, today's video is for the students of class 8. So then yesterday we had no videos as it was the World Cup final. Unfortunately for us, our team lost, but they had given a huge fight. So let's not get disheartened, right? There is always a next time. Anyways, so as I was given you a holiday actually yesterday. So today we are back with the important chapter of sets. Okay. And I think that this part will bring us almost towards the end, because with this I will be remaining only the last part of sets, and sets is actually a large chapter of class 5. That's why it takes a long time to explain it, because it has many things which we can't do in one video, right? It will be really complicated. So as you can see, today I have operations on sets. So basically we have few things called operations. Just as we have addition, subtraction, multiplication, we also have some operations on sets. First one is we have union of sets. Union of sets. This says that if two sets are there, suppose A and B, and suppose A has the elements A, B, C, and B has the elements C, D, E. So union means what? Without repeating any elements, we have to actually jot down all the elements of these two sets in a single set. Union is denoted by this sign. A union B equal to what? A, B, C, D, E. See, understood? What is that is? Here C and C is repeated here, right? But we didn't repeat that C. We just jot down the elements here without repetition. What are the respective elements A, B, C, D, and E? That is called the union of sets, okay? And overlapping of sets. It is also called intersection of sets. This will be easier for you to understand. This is actually what? Suppose we have two sets A and B. Again I have, let's take this time A equal to ABC. These are the elements. And B equal to BCD. A intersection B. That means we have to write down the common elements of A and B in a single set. A intersection B is denoted by this sign. So this is a U which is used to denote the union, and for overlapping and intersection it is the opposite of U. Okay, that's it. So A intersection B, what will it be? The common elements of A and B. What are they? B and C, as you can see here. So this is what union, writing down the elements without repetition of the common elements if it is there. And intersection means just writing down the common elements in a single set. But this is the concept about union and intersection of sets. Another thing we have is A minus B, difference of sets. Difference of sets, what is it? Suppose I have set A equal to ABC, B equal to BCD. A minus B means what? The set A minus the common elements of set A and B. That means we have to take out the common elements between A and B from A. So A minus B means what? A minus A intersection B actually. This means the set A, from this set A we have to remove the common elements of set A and B. So what is this actually? Set A is ABC minus A intersection B, we know is the common elements between A and B, which are here B and C. So now you tell me, A, B and C, from that B and C get removed. What remains? That remains A. That is the answer of A minus B here. So if it is given B minus A, then the set B, from that we have to remove the common elements of sets A and B. Then that will become what? B and C are common between both of them. From this set BCD, B and C will get removed. So D will remain as the element. So then B minus A will be equal to D. Okay. So that is the concept. I am writing it actually for you. equal to B, sorry, minus A intersection B. A intersection B means what? The common elements between A and B, right? Okay. So this will become B is the set BCD. A intersection B, the elements common of A and B, which are B and C. Now from B, C and D, B, C get removed. This becomes D. Okay. That is how the difference of sets work. Another thing we have a complement of a set. Suppose I have a universal set like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And I have a set A equal to 1, 2, 3, 4, 5. Okay. So then what is A complement? The complement is denoted by this like apostrophe. Okay. Like this only. The comma sign over the upper side, the upper case. The complement of A, what is it? The elements which are in A that have to be removed from the universal set to get the complement set of A. That means the numbers which are in universal set, from those the numbers of the set A have to be removed. The remaining elements will be the complement of set A. So complement basically means universal set minus the given set. Okay. So if I remove these 5 elements of A from this universal set, then 6, 7, 8, 9, 10 will remain. So that's how we got the answer here, as you can see. So we figured it out. We learned about union of sets, intersection of sets, difference of sets, and complement of set. So these are the operations on sets, which we will now solve a few questions for you. Let us see what questions we have. So this is very important. Keep everything in mind while solving the questions. And let us proceed. Understanding the basics of these operations is very important. Okay. Various types of laws actually, which we will see. No need to go for the laws. We have proving actually to prove the laws. Laws are given by statements. We have to prove the statements, nothing else. So first question coming on your way. I have a set A given by x such that x belongs to natural numbers, comma 3 less than x, s less than equal to 6. Alright. And another set I have b equal to x such that x belongs to natural numbers, comma x less than 4. Wait, will be the C? It has whole numbers actually. Okay, sorry, it's less than equal to 4. Alright. We have been told to find A union B, comma A intersection B. We know these signs. So let us first find the sets A and B. A is what? X greater than 3. So I have learned that x greater than 3 and x less than equal to 6 are the equations. All should be natural numbers. Greater than 3 we have 4, 5, 6, 7, 8, 9. Keeps going on. For less than equal to 6, for natural numbers we have 1, 2, 3, 4, 5, 6. Okay. Now what are the elements common then? 4, 5 and 6 are common. Okay. So then the elements of set A will be the common elements of these two equations, which are 4, 5 and 6. So we have got A. Similarly for B, they are saying it is whole numbers less than equal to 4. So there actually I can simply write 0, 1, 2, 3, 4. They are the whole numbers less than 4 and including this equal to 4 is also included. So these are the two sets A and B. Now A union B means what? We have to just jot down the elements of these two sets without repetition. Okay. repetition. So without repeating the elements, there may be common elements. What are they? 0, 1, 2, 3, 4, 5, 6. Carefully see, we have a common element 4 here, but I am not writing it two times. That's the concept of union. If you have two common elements, write that common element only once in the union set. Okay, understood? And for the intersection B, we have to find the common elements or element of A and B, which is in this case only 4. 4 is the only common element, others are all different. So A intersection B equal to 4. And that's the answer of this question, as you can see on your screen. Very easy, we found out the sets by doing this, solving the equations, and that is also very easy. Then A union B means all the elements without repetition of any element of the sets if anything is there. 4 was repeated, but we wrote that only once. That's the concept. Anything can be repeated 2 to 3 times, but write it only once in the union set. Okay, everything should be separate elements, no same elements. And A intersection B, that is the common elements of A and B, just the opposite. Common element is 4 among both of them. That's 4. That's how you have to do the sums. As you can see, basically all the sums will be on this. A little bit larger actually, large type of sums will be there, following the same rules. Let's see question 2. Okay, surprisingly we again have the same sets, I think. X belongs to X as that 3 less than X. Oh, sorry. X less than equal to 6. Yes. I have B. X as that X belongs to whole numbers. X less than equal to 4. But then will the question be same? Not to be the case. We have to find A minus B. Oh, sorry. Comma B minus A. We know how to do that. First, let us find the sets. Previously, I solved it for you. If you see my previous part, the elements of this is 4, 5, 6. Okay. Same thing. Greater than 3, the natural numbers 4, 5, 6, 7 goes on. Less than equal to 6, are 1 to 6. 1, 2, 3, 4, 5, 6. The 4, 5, 6 are the common elements of both the equations. So 4, 5, 6 is the set A. What is the set B then? B is the whole numbers less than equal to 4, which is 0, 1, 2, 3, 4. Now, so A minus B is what? A minus the common elements of A and B, or A intersection B. And B minus A is what? B minus the common elements or intersection of A and B. Alright. So let us first find A intersection B. Okay. So A intersection B is what? Common elements of A and B, only 4 is there. So A minus B will be equal to the set A, 4, 5, 6 minus the element 4 or the common element. Similarly, B minus A will be equal to set B or 0, 1, 2, 3, 4 minus the common elements of both the sets, which is only 4, the intersection. And then we get, if we remove 4 from this, 5 and 6 remains. And similarly, if we remove 4 from this, 0, 1, 2, 3, 2, 3 remains. And that's how you have to do it. Very easy. Why I did that? Because A minus B already learnt. A, the set A minus the intersection of these two sets. That's why I got that. And in the same case for B, B minus equal to B minus the intersection of both the sets. And if you just remove the element 4 from both the sets, you will get the respective answers. Very easy actually. Learn the theorems, the process. Let us see my first part. You can solve all these sums. But we have some hard sums actually towards the end. Not hard, but they are actually based on laws. So let's proceed to now. We have different sets. Okay. We get bored when we have same sets, right? I will not let that happen. X belongs to whole numbers. Comma 4 less than equal to X, X less than equal to 8. And here I have another set Q as well. Q is what? Let me see. X as a base belongs to natural numbers. Alright. X less than 6. Okay. They are telling is what? Oh, that's a good question. Is P intersection Q a subset of P union Q? Oh, wow. Now here I told you in the previous video, we will get the actual operations of subsets in the next video, universal sets. I hope you can see. So first, what is our task? Find out P intersection Q and P union Q. Before that, let us find the sets P and Q. Set P is what? The elements within this range. They should be whole numbers. So less than equal to is there. So 4 will be included. 5, 6, 7 and 8 will also be included. 4, 5, 6, 7, 8. They are all whole numbers satisfied. Similarly, Q is what? Natural numbers less than 6 means 1, 2, 3, 4, 5. We have the sets. Now P intersection Q. This is what? The common elements of P and Q, what are they? I think you can see 4 and 5 are common among both of them. So let's write them down. And P union Q is what? Just jot down the elements without repetition of the common elements. What are they now? 1, 2, 3, 4, 5. Again 4, 5 is there. No need to write it again. 6, 7, 8. So they are asking us, is P intersection Q a subset of P union Q? Now for A to be a subset of B, all the elements of A should be there in B. So are the elements of P intersection Q or 4 or 5? They are in the set P union Q of this. Yes, 4 and 5 are there in this set. Right, and that's the rule for A subset of B. All elements of A should be there in the set B. And that's satisfied. Therefore, as all elements of, you have to write this is important. Intersection Q are in P union Q. Therefore, P intersection Q is a subset of P union Q. That's how we come to the end of the question. First of all, we find out the common elements of the intersection, then the union or jot down the elements without repetition. Then we have to see P intersection Q, all its elements are there in the P union Q set. And that's the case here. So the condition is satisfied and statement is absolutely correct. As you can see here, this is the logic. As all elements of P intersection Q are in P union Q, therefore P intersection Q is a subset of P union Q. If you see my previous video, you will learn about subsets. It's very easy. Let's see the next question. I told you this it is fun actually. If you know the theorems, you can have this chapter in your arc, the scoring arc, which you all like. Other question. Now I have A equal to 5, 6, 7, 8, 9. Again I have B equal to 4, 5, 6, 7. C equal to 1, 2, 3, 4, 5. Okay. They are asking, to find a few things. Find A union B union C and A intersection B intersection C. So we have dual operations here. First find this A union B, then that set, and again its union with set C. Same the case for intersection. Okay, for A union B union C, let's write, or A union B union C. So first we have to solve this one in brackets. What is A union B? All the elements of A and B without copying the common elements. So there are 4, 5, 6, 7. 5, 6, 7 are common. Don't write them again. 8, 9. So A union B equal to, or A union B is what? 4, 5, 6, 7. copying now the elements without repeating them. If there is any common elements, 5, 6, 7 is common, don't repeat them, that's it. 4, 5, 6, 7, 8, 9. That's A, union B. Union what? Set C, which is 1, 2, 3, 4, 5. Okay. Again, here also the same case. Don't copy the common elements. Write them only once in the union set. So what is this? Common elements of 4 and 5. Write them only once. So this will become equal to, and this also equal to 1, 2, 3, 4, 5. I am not writing 4, 5 again. They are repeated. They are common. This will be 6, 7, 8, 9. And that's what I think is the answer of this question. Okay, no, but that's the first part. Again, the second part. A intersection B intersection C. Similarly, if I do the intersection of A and B, but to find the common elements between them, their common elements are 5, 6 and 7 if you see properly. So A intersection B is what? 5, 6, 7. This set's intersection with set C. 1, 2, 3, 4, 5. Understood? First we found out the intersection of A and B of the common elements of them, 5, 6, 7. We got that set, its intersection with set C again. As you can see. So this will become what? The common element between this and this is only 5. So the answer is for you here 5. That's the two respective answers. You can be a master of this chapter if you know the basics. Don't get confused here. Just solve the brackets first for both of them. A union B we find by writing down the elements without repeating them. Union the set C again without repeating the common elements. We write them in only once in one set. Just jot them down without copying. Means repeating any element. Then for A intersection B intersection C, find out the common elements of A and B first. Then 5, 6, 7. Its intersection with 1, 2, 3, 4, 5, the set C. These two's common element is 5. That's the answer of this question. So very easy. If you carefully see the question and do step by step, it might take a little bit time. At the end, you will get a neat and clear answer. Very easy. Let's proceed accordingly. Alright. So question 5 is coming on your way. I have A equal to 0 and 2, 4, 5. 3 is telling what have I done? We don't need you. Why to copy so many elements? 3 must be a enemy of us. Right? Who cares? Let's write down the sets. Just joking. And C is equal to 0, 3, 6, 9. What elements? But they do have some significance in the question, right? Let's see. Okay, I can show this. Okay, we are proving. We are beginning proving now. Show that A union B union C. A union B union C equal to A union B union C. This has a hole, this has a hole. We have to show this if it is true or not. On the other side, we have A intersection B, A intersection B intersection C equal to A intersection B intersection C. Again, no worries. It's very easy. To solve step by step, I told you. Just have to see the left hand and the right hand side are same or not. For this one, let's write. What is the set A? 0, 1, 2, 4, 5. Its union with what? The union of B and C. B and C's union is what? Just jot down the elements without repeating the common elements. If I do that, I get 0, 2, 3, 4, 6 is there 2 times, add it only once, 8 and 9. It becomes like this. Now again for this one, alright, okay. This will be equal to what? Now A union B. What we did is A is set A union the set union of B and C. We did this first. Now we have to do the union of A and B first in the right hand side. What is it again? Jot down the elements without repeating them. This becomes 0, 1, 2. 2 is repeated, 0 is repeated, write them only once. 4 is also repeated, write it once. 5, 6, 8. This is the union of A and B which we have been asked. Union with the set C. You understood that? First we have been told A union B union C. B union C is this. And then A union B, which is this, the union of these two, union the set C. Now we have to see both these are equal or not. What will this become? So union of these two sets is what? Again, without copying the elements. 0 is there 2 times, write it once. 1 is there, 2 is there 2 times, write it once. 3, 4 is there 2 times, write it once. 5, 6, 8, 9. That's the union if you write all the elements of these two only once. Okay, without repeating. And this union, again, 0 is repeated, write it once. 1 is not repeated once. 2, 3, 4, 5, 6 is repeated twice, write it only once. 8, 9. So, are the elements of both of these sets same? 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 8, 8, 9, 9. They are same. So, this statement is justified, therefore proved. So, let me just draw this like for you. Just to specify this process is for this sum. Might get confused. Very easy. Just solve the brackets and write according to the question. No need to hurry. Solve step by step and see if the left hand side and right hand side are same. If yes, then proved. If not, the question is not right or the proving is not actually correct, then say not proved. Okay. Very easy. Question can never be incorrect. Okay. They might ask you here, is it proved means correct or not correct? If yes, then yes. No, then no. Don't do like that. It should be correct, but the question is like, no, don't do that. Be practical and particular. Go to one direction. You can't run in two directions, right? You will fall over. Here the case, you will lose the marks. Okay. Now this thing. A intersection B intersection C equal to A intersection B intersection C. Let's write. So the set A is, or set A is 0, 1, 2, 4, 5. Its intersection with what? The intersection of B and C. So B and C's intersection of the common elements of B and C are 0 and 6. If you observe properly. Okay. Equal to what? First, let's find A intersection B. The common elements of A and B are what? 0 is common, 2 is common, 4 is common. Okay. So 0 to 4. Its intersection with the set C. 6, 9. Now the intersection of these two sets, what is it? Only the element 0 is common. Let's write 0. Don't take 0 as light. And in this case as well, only the 0 is common. Both elements are same in left hand side and right hand side, therefore proved. Easy. Very easy actually. Just do accordingly. Know where the brackets are. Give preference to the brackets. Okay, and just do it and see if LHS or left hand side equal to RHS. If yes, these questions are then justified. We are doing well actually. We now know how to do the proving, how to do intersection, difference. I think difference one sum was done, yes, of course. Let's see a few more examples of these. Question 6 coming up your way. I have here a equal to 6, 7, 8, 9. I teach 7, 8, 9. Jokes apart. B equal to 3, 4, 5, 6, 7. Okay. The less the elements, it is more easier for us. But the question maker tells do hard work. I have also worked hard to write the questions. I want you. Okay, let us work hard. Set C is set C is 2, 4, 6, 8. Okay, no more sets. So these three only. Find. Okay, wow. Little bit complicated, but again I am telling. Just do it accordingly. Find A intersection B union A intersection C. We are now telling. We know how to do this. You can't beat us, right? Let's see. Let's defeat this sum. First, A intersection B. So A intersection B means what? The common elements of A and B. Which are here? 6 and 7 are the common elements. Easy. 6 and 7. Right, that are A intersection B, the first part in brackets. That means the common elements of A and B. We got it, 6, 7. Union what? The common elements of A and C now. If you observe the common elements of A and C and the section C equal to common elements of A and C, 6 and 8 is common between both of them. So this becomes 6 and 8. Is this stuff? No, it can't be, I think. It can't be. If you know this, you are pro in this chapter. First part A intersection B, union A intersection C. Common elements of A and B, union common elements of A and C. Got it? There you go. Now for union, we don't have to repeat the elements, write them only once. This becomes 6 is written twice. I will write once, 7 is there, 8 is there. Game over. Such a big thing, right? Looks this sign, this sign, this sign. Nothing. We know now. We know how to do this. We know how this last part is. Now I think I was telling you in the previous video, is the actual part of this chapter is very hard. I am admitting it's not hard. Okay. It's not hard. Don't take it as hard, take it as fun. Solving sums for fun. Very easy. Good sums, but see, these things actually come in exams is large number. This chapter has a huge weightage in the exam. So then imagine if you know this, then how many marks you can score in maths. Right? It is important. In that sense, it is important to learn the formulas. Okay. Difficulty? No, we don't now have difficulty. We now have the level of easy. Yeah. Let's see. So now I have a question. P equal to factors of 36. Okay. You can't fool us with some new things. Okay. We know what is factor. We have learned in class 3 and 4. Every one of us. And Q is factors of 48. What is the thing we have to find? Let's hope it's something hard. Okay. Fine. P complement Q intersection Q. So guys, give me just 1 minute. So I will be back within 1 minute. Just give me 1 second. Guys, sorry for the delay, but we are back with the sum. Nothing problems there. So P intersection union intersection P complement intersection Q. Okay, so let us first find the set P. P is what? Factors of 36 I will write down directly. 1, 2, 3, 4, 6, 9, 12, 18, 36. You know factorization, I am not going to bore you with that. And the set Q is what? Factors of 48. So 1, 2, 3, 4, 6, 8, 12, 16, 24, 48. As you can see, these are the factors of the required sets we have been given. What they are telling is P complement intersection Q. Okay. Now let me tell you one thing. P complement. That means we have to remove the elements of set P from something. But if it was given a universal set, then we could have removed the elements of P from that to get the P complement. But as there is nothing given here, so the set P and its elements can't be there. Okay, see P complement, but complement from where? Means I have to remove the elements of P. We know P complement equal to the elements of P have to be eliminated from the universal set. The remaining elements are the P complement. But no universal set is given. So all the elements of P can't be there in this intersection. So actually this means what? P intersection, P complement intersection Q is only Q. Okay, means because see P's elements can't be there because all the elements will get removed. Complement of a set without a universal set means all the elements of that set will get removed. So we cannot consider any set or element of P. We have to only see the elements of Q, and that means what? We have to do Q minus P. Right, that is Q minus the whole P set. Only the set Q can be there because all the elements of the set P have to be removed. Whole set's complement, so all elements will get removed. So Q minus P means what? Or the only set only Q. That means what? Q minus Q intersection P. Means the P's means like thrown out of the house. You can have nothing. Take out your bag, clothes, everything and leave us alone. Just like here. All its elements have to be eliminated because of the absence of a universal set. So remember this. P complement without a universal set means the all the elements of the set P will get removed. Okay. So suppose you are given find P complement of this set. No universal set. What there will be the answer then? Suppose I have given you the question. Find the set complement of the set P and the set is factors of 36. The answer then will be null set. No element of P will be there, so only null remains. Write it like that then. Here the case, only the set Q excluding the elements of set P. He is thrown out. He is the main culprit here. Okay. So this becomes what? The set Q, which is 1, 2, 3. I am writing for you. Let me make it look easy for you. This is actually a good sum. It has a means logic. When a complement of a set is given without universal set, remove all the elements of that set. It should be totally wiped out. Remember that. So this set 1, 4, 3, 1, 2, 3, 4, 6, 8, 12, 16, 24, 48 minus Q intersection P, or means the common elements of P and Q, which are 1, 2, 3, 4, 6. Means Q is telling that I want to have the whole property myself. I will give you not even 1%. Okay, Q, we accept your terms and conditions. 2 means solve this sum properly. What are the common elements here? 1, 2, 3, 4, 6, 12. Is anything else common? 18, 16, 21? No, not to be the case. So these are the common things. 1, 2, 3, 4, 6, 12. They are common. Alright. So that means what? This set Q minus these elements. Remove these elements from the set Q. This becomes what? 1 gets removed. That is, this get cancelled out. 1, 2, 3, 4, 6, 12. 1, 2, 3, 4, 6, 12. What does it remain then? 48 is left as well. Don't think it's cancelled. So it remains 8, 16, 24, 48. Very good sum. I think the best sum we have had till now. P complement without universal set, all wipe out all the elements. Q should be left alone. Means the common elements which are means attached to Q or of P, that will get removed. So this turns out what? Q minus P, or Q minus the intersection of Q and P. We have learned that A minus B equal to A minus intersection of A and B, like that. So the set Q minus the common elements of Q and P, and just remove them accordingly to get the answer. Good sum. I was telling it's easy. So this is hard. So we have a means few critical analysis which we are having here. So these are actually tips and tricks type of a thing. You can be given this type of questions, right? Those who are going for Olympiads, competitive exams. I will also show you competitive exam sums later on, after we just complete all the means types of chapters, all type of sums, to get the complete understanding. So then you will see this type of sums in frequent cases. So remember these things then, okay, to solve them smoothly. Let's see the next question. So we are now becoming learned, very educated. We were illiterate about sets before the start of this video, but now we are educated, right? Let's see. Let's put this education to use. And the next video we have, I'm giving you the topic. It's a funny one. Drawing and sets. Some of you can imagine what is it? Yes, the next topic of the part sets will be Venn diagrams. Very interesting. How can you find a set from a diagram? Is it possible? We will find out. Let us focus on this. This topic is stating we are not completed. Solve us. Okay. I am solving it. Actually, we are solving it. So B is 4, 6, 8, 10. Another set C is there as well, I think. So C is what? 3, 4, 5, 6, 7, 8, 9. Question maker is telling I can give you a relief. I am not giving you in set builder form. You don't have to do that conversion. Okay, accepted. Thank you. Thank you for me and all of you, I think. Okay. Now, they have told us find A minus B comma B minus C. What? That easy? Really? The question maker now is telling you saw a very hard sum before. So it's my duty to make it easy for you. Thank you again. A minus B. What is it? Equal to A minus A intersection B. A minus the common elements of A and B. The set A is 6, 7, 8, 9. Minus the common elements of A and B. What is it? 6 and 8. Nothing else is common. They are all separated. This becomes, remove these two elements, please. 7 and 9 remain. That's it. A minus B. Finished. Okay, let me write here. Or A minus B. This A is not looking good, right? My A's are not good, I know. Yeah. And as we equal to this, we know the formula. And what about B minus C? B minus C is also equal to B minus B intersection C. That means the set B minus the common elements of sets B and C. This becomes what? The set B is 4, 6, 8, 10. Common elements of B and C, they are 4, 6 and 8. 10 is left. He's feeling disappointed. What to do? Again, remove these three. Respectively, this becomes 10. Solved. Finished. Question 8. A minus B, A minus common elements of A and B. 6, 7, 8, 9 minus the common elements 6 and 8. 7 and 9 remains. That's the answer of A minus B. B minus C, B minus the common elements of B and C. Set B is this minus the common elements are 4, 6 and 8. Remove these 3 respectively, 10 only remains. So solve, very easy for you. This is easy actually. We have done very hard things considering this one. It's good to do some easy things sometimes. Otherwise your brain will get damaged. Question 9. We are heading almost towards the end of this funny and interesting part 4. Let's see. But this happy ending as for us, I don't think it's that happy. It's hard. Okay. Let's see if it's really hard or not. A equal to 1, 2, 3, 4, 5. B equal to 2, 4, 6, 8. As long as these are not in means set builder form, no, a lot of time is saved for you. Not to be the case, you can convert it from set builder to roster. It's easy. One thing we can summarize from this roster method is really means he has no importance. He is taken for granted. But that's very important, okay? Because these are in direct form, no, you can solve it quickly. So roster form, you are also called as jot down method. Now verification. Oh no, we are not studying law, but we have to do verification. We have A minus B intersection C. Okay. Equal to A minus B union A minus. Oops. A little bit big one. Okay, let's solve it. Set A. What is it? 1, 2, 3, 4, 5. Minus B intersection C. The common elements of B and C are 4 and 6. As you can see, 4 and 6 are common between them. So the set A minus the common elements of B and C. Alright. So let me just check one thing. Let me just check that one thing. If this sum, sometimes sums are incorrect, okay. So remember that. Still I am just seeing. Okay. So see this. Here what we have is the common elements. So set A minus the common elements of this intersection of B and C. Now from these two C we have to only remove the common thing. Okay, right? If it was A minus B suppose. Okay, then only the elements which are common among A and B, they have to be removed from the set A. And here also, what are the common elements among A and B? B and C here. Okay, B and C here, the common elements are 4 and 6. But A minus B intersection C means this minus this. Okay, actually no, not that one. See, this minus this means what? Now A minus B intersection C we have got. This will become what? What are the common elements now? This will become 1, 2, 3, 4, 5 of set A minus the intersection of these two sets now. The intersection of these two sets, it is actually 4 only. So this becomes, remove the element 4. 1, 2, 3, 5. So let me just write LHS. So you know for verification, right? LHS should be equal to RHS, or left hand side equal to right hand side. So for the left hand side, what we did, set A minus the common elements of B and C, which are 4 and 6, or the set A minus the common elements of these two sets, which is 4. Remove it, we get 1, 2, 3, 5. That is LHS. Now let's solve for RHS. A minus B, that means the set A minus A intersection B, union A minus C means, let me write properly, the set A minus the intersection of A and C, the common elements of A and C. No worries, let's do it. What does it become? Set A is 1, 2, 3, 4, 5. Minus the intersection of the sets A and, means the common elements of the sets A and B. What does that become? The common elements of A and B, what are they? If you see properly, it is 2 and 4. Okay. Okay. Right, A minus B equal to A minus A, common elements of A and B. Similarly, A minus C equal to A minus common elements of A and C. Union the set A again is 1, 2, 3, 4, 5. Minus the common elements of A and C. They are 1 and 2. Okay, not 1 and 2. Sorry. Not 1 and 2. Why? How can it be 1 and 2? The common elements. The 3, 4 and 5 actually. 3, 4, 5. Okay. Common elements of A and C, common elements of A and B. Accordingly, if you solve, so remove this 2 and 4 here, make it look more neat and clean. Becomes 1, 3, 5. Union with, again move 3, 4, 5 here, please. We need clean space. Union 1, 2. So now, if you write all these elements without repeating one of them, the rule of union, this becomes 1 is repeated, write 1 once, 2 is there, 3 is there, and 5 is there. RHS. So LHS's elements is equal to the elements of RHS. Therefore, LHS equal to RHS. Therefore, verified. Yes, we have verified it. So very simple. Set A first, which was here A, the 1, 2, 3, 4, 5 minus the set of intersection of the elements of B and C, or the set of the common elements of B and C, which is here the common elements are 4 and 6. And now this set minus this set, that means what? This set minus the common elements of these two sets, or 1, 2, 3, 4, 5, or A minus the common elements of these two sets, it is only 4. Remove the 4, 1, 2, 3, 5, and that is LHS. For RHS, it was A minus B union A minus C, easy, which is A minus the common elements of A and B, which is 1, 2, 3, 4, 5 minus the common elements of A and B, it is 2 and 4. 2 and 4 gets removed, 1 and 3 and 5 remain. Union with A minus C means the set A minus the common elements of A and C. Observing that becomes the set A, or 1, 2, 3, 4, 5 minus the common elements of A and C are 3, 4 and 5. Remove 3, 4, 5, 1, 2 remains. So 1, 3, 5 union 1, 2 without repetition of any elements, we write it 1, 2, 3, 5 is the elements of RHS. As LHS equal to RHS, the elements, therefore verified. Is correct, proved. Wow, long question. Let's take a deep breath. Okay, I can take the breath while writing the next sum. Actually, the last sum for today, or the last sum for this part 4, or operations on set, which will help us to go to the part 5, or the last part of sets for class 8, which is Venn diagrams. Wow, that will be an amazing session. Watch it. Okay, another big proving, the last one. Let's see. We now know everything. Okay, set A is given 1, 2, 3, 4, 5. Good numbers. Set B is given 3, 6, 9. Multiples of 3. They are looking nice. And another set C is also given, I think. Yeah. Set C is what? Let me tell you. The set C is equal to 0, 1, 2, 3, 4, 5, 6 actually. Alright. Oh, very good. What we have to do is we have to again verify. A union B intersection C. It should be equal to what? A union B intersection A union C. No, we know everything. Let's do accordingly. LHS. So this is the LHS equal to what? A, the set A 1, 2, 3, 4, 5. It gets united with the common elements of B and C. What are they? 3 and 6 is common. Sorry, 9. We have to leave you. Okay, 3 and 6, union 3 and 6. That is it. A, the set A union the common elements of B and C, B intersection C. This is it. So now without copying means repeating any elements, 3 is here written twice, so write it only once. So this becomes 1, 2, 3, 4, 5, 6. No repetition. That's it for union. That's A union B intersection C. LHS is done. RHS. A union B means all the elements of A and B without repeating them. Common elements are 3. Only 3 is common. Okay. So repeat. Don't repeat 3. Only write it once. So it will be 1, 2, 3, 4, 5, 6, 9. And A union B. Okay. This intersection. Then A union C. Again, don't repeat the common elements. 1, 2, 3, 4, 5 is common. Both of them. Write it only once. So this becomes 0, 1, 2, 3, 4, 5, 6. All have to be written once in union, okay, of two sets. Right, A union B and A union C, their intersection now. So these two sets common elements, what are they? 1, 2, 3, 4, 5, 6 is common among them. Okay. 1, 2, 3, 4, and 6. Aren't they? Their intersection means common elements. That's it. RHS is this. Now see, LHS equal to RHS, and that's the rule for verification. Therefore, LHS equal to RHS. So verify. There you go. Answer finished. Verification finished. Topic finished. Operations on sets. Let's see a little bit revision. The set A union the common elements of B and C, which are 3 and 6. Union means no repetition of the common element. Write it once only. So 1, 2, 3, 4, 5, 6 in the union of LHS. Okay. For RHS, A union B means all the elements of A and B without repeating the common elements only once. 1, 2, 3, 4, 6, 9. 3 is written once. Okay. As it is a common one. Intersection A union C means the elements of A and C without repeating the common elements. 1, 2, 3, 4, 5 are common. Write them only once. That becomes 0, 1, 2, 3, 4, 5, 6. Okay. Intersection of these two sets means the common elements of these two sets, which are 1, 2, 3, 4, 5, 6. If you observe, which is the required part for RHS. As all the elements in LHS equal to the elements in RHS, therefore this statement A union B intersection C, but A union B intersection A union C, this is verified and absolutely correct. So then in today's video, wow, we learnt all the operations on sets. We did union, intersection, difference of sets, complement on sets, a very important theorem of that. A complement of set without any universal set, remove all the elements of that set, make him leave the house, like that only. We learned that. Then we did different types of proving, in which we know that LH is equal to RHS in any kind of proving, that is the main criteria. And that's how we actually are now the masters of this part. Actually, 4 parts of sets. So part 5 should be more interesting than this. I think it's actually more interesting. So in the next video for class 8, which I assume that within 2 days it is going to be coming, we will do part 5 or the last part for sets for class 8, which is Venn diagrams. Very interesting drawing and sets, you can imagine. That's what, how is it possible? We will see. Everything is possible in the world. Okay. So till then, if you found my video very informative and helpful, and all the sums of this interesting topic were clear to you, then please like and subscribe my channel. It means a lot to me. Till my next video on this chapter on the beautiful topic of Venn diagrams, with a lot of love from my side. Take care and goodbye. Thank you.